Hi everyone, so here's a video on a few problems from page 354, just in case you had some trouble with those. Now the pictures aren't so great. Okay, so here's number 5, page 354, number 5. And again, this was all talking about the 9-5 video on the inscribed angle theorem. All right, so we got to do some work here. I'm trying to find angle x because I tend to go in alphabetical order if I can, and I see that angle x is an inscribed angle. That's the angle I'm looking for, which means that I need the measure of this arc that it cuts off, its intercepted arc. So I look over here and I see a 50-degree angle, and it's the only angle they gave me. That is also an inscribed angle, which makes the arc 100 degrees, which then makes x, because it's an inscribed angle of that arc, 50 degrees. Okay? Then I look at z, just because it's right there for me, and I see that it's an isosceles triangle. So I see that these two angles then would have to be congruent because of the isosceles triangle theorem. So I take the triangle, I subtract 50 from the triangle, and I get 130. Now I divide that in half because those angles are equal. So 130 divided by 2 is going to give me 65 degrees. All right, so I know that this is 65 and this is 65. All right, well, I'm trying to find this arc over here. So you actually have a couple of ways you can do it. You can say that this angle here is inscribed, this angle here is inscribed. And so if angle Z is 65, then angle Y is the arc that it intercepts, so it would be double, so 130 degrees. So you're really having to look hard for these inscribed angles and the arcs that they intercept. All right, let's try another one. Number 6. Okay, I know my picture is not that great. I had to take a picture and it just didn't do a very good job. All right, so the one thing that you have to look for here, and this is where they start to get challenging, is the center of the circle. So if you remember, I said if you see a diameter, that's one of those corollaries. So angle x is actually inscribed inside a diameter, inside a semicircle, so it makes x 90 degrees. Okay? So I'm going to put a box there. Now, it also, if you notice, angle z is also an inscribed angle in a semicircle, so it makes angle z 90 degrees. And wow, if you flip this upside down, angle y is inscribed in the bottom semicircle, so y would also be 90 degrees. So you do have to look for that center of a circle because it's cutting the circle into a semicircle, which would be corollary. I think it was corollary 2. Corollary 2. Okay? All right. Number 7. Okay, see, these are getting harder. Now I notice the congruent marks, but it's not a triangle. But that means that these arcs, these are congruent chords, so that tells me this arc and this arc are equal. All right, so the first thing I decide to do is look at 76. And 76 actually happens to show me that this is an inscribed quadrilateral. And from the corollaries, I learned that inscribed quadrilaterals, opposite angles are supplementary. So x plus 76 then has to equal 180 degrees. So I'm going to take 180, subtract 76 from it, and get that x is 104. All right, so this is 104 degrees. Now, it is a really wide inscribed angle. And so it actually intercepts this entire arc, which makes that arc 208. And because that arc has these congruent chords, that means each of those arcs is congruent. So I take 208, I cut it in half, which gives me y to be 104. All right. Z is also that funky inscribed angle with a chord and a tangent. So its measure is half of the arc it intercepts, which is that 104 degree arc, which makes Z 52 degrees. All right, number 8. And you're noticing that these are getting a little bit more involved each time. All right, so I have to look. I see a lot of congruent chords here. So I see that this is congruent to this here, so it makes this and this arc equal, which tells me that x has to be 80 degrees. Congruent arcs have congruent chords. Well, then I jumped to y, and y is an inscribed angle. Its vertex is on the circle, and it intercepts that 80-degree arc, which makes y 40 degrees. Okay? All right, but now I got to find angle z. I have to do some work. So this is 80 degrees, this is 80 degrees, this is 80 degrees. So that's 240 degrees. This is the rest of the circle. So I do 360 minus 240, which gives me 120. So that's telling me, even though it's not to scale, guys, that this is a 120-degree arc, which makes z an inscribed angle of it. Z is an inscribed angle of it, which makes z's measure half of it, so 60 degrees. All right, one more. Doing okay? I know that this is hard, and you guys are doing a great job, and don't panic, because I will be there for you. All right, I notice these. Gosh, parallel lines tell me a lot of different things. But if you notice really carefully, in this case, those parallel lines have a transversal, creating alternate interior angles. So I actually know that angle x and this angle down here are equal. And I see that angle x has an arc it intercepts of 100 degrees. And so it's 1/2 of that, so it's 50 degrees, which makes this 50 degrees. And then y is the intercepted arc of x, which makes that 100 degrees. All right, so we've got a little bit more work to do to find z. I see that this arc is 100. I see that this arc is 90, and I see that this arc is 100. And so the arc that I need is everything else in the circle. So I'm going to do 100 plus 100 plus 90, which gives me 290. I'm going to subtract that from 360 degrees, giving me didn't need to do that, sorry. 360 minus 290, yikes, Coach Fred, is 70 degrees. Okay, so this is 70 degrees, so that means z would have to be half of that. See, even I make dumb, careless errors sometimes. So z would have to be 35. All right, guys, I got to get back to my conference. I just took a quick 15-minute break to make these videos for you. I really hope it helps. Have a great night.